Okay, good day, class. Welcome to Triple M Online Academy. So this will be our first online lecture for ES1. So today, before we proceed with the different techniques used in that we will be using in our plates, first have to give you an introduction to projection. So for this lecture, hopefully by the end of this lecture, we should be able to describe and differentiate the different types of projection, differentiate primary and auxiliary reference planes, and lastly, draw an adjacent view of a figure given only two views. Okay, so let's proceed with the types of projection. Now, there are multiple types of projections now, but these are the more commonly used ones when it comes to engineering applications. Okay, so the first one is your multi-view projection. So the multi-view projection is just a two-dimensional view or a collection of two-dimensional views of a three-dimensional objects. So as we can see, this one right here is your top view, and this is the front view of your object, while this is the side view. Okay, now you can see that there are letters here now. So we have a line separating two views, and we also have a line here separating these two views. Now we call this top view as your horizontal reference plane. This is horizontal, and FRP stands for frontal reference plane, being that it is the front view. It's called horizontal. This HRP is called horizontal because it is parallel to the horizontal plane. And this one is last, your perspective reference plane. Okay, so this is multi-view. Again, multi-view is just a collection of 2D views to represent a three-dimensional objects. Next, we have your isometric drawing. So the isometric drawing is in engineering, it's the most commonly used uh, type of projection to represent a three-dimensional object, because it gives us a very or a readily available three-dimensional um, view of our object. Okay, so this is done by creating a 30-degree angle right here, and this is actually, if we relate it to our to the multi-view, this will be the front view, this is the top view, and this is your side view. Okay, so it's called isometric because in all three axes, so if I say this is my x, this is y, I'm sorry, x, y, I'm sorry, this is z, y, z, I'm sorry, this is supposed to be x if you follow the right hand rule. No, this is x, this is y, and this is z. Okay, so in all of the axes, the 1 unit in the x-axis is exactly equal to 1 unit in the z, and also equal to 1 unit in the y-axis. That's why it's called isometric view. And notice that in isometric views, all parallel lines appear parallel, and there is no what we call as a vanishing point now. Okay, so unlike your perspective view, so these are the um, other types of projections now. So in perspective view, there is your vanishing point. So the vanishing point is where your parallel lines, so this one and this one, appear to converge. Okay, so the perspective view is more of a um, this is commonly used in architecture, no, because it gives us a better, or it gives us a more real world um, representation of the 3D object. Then we also have your other pictorial type of projection, which is the oblique, wherein you are highlighting one of the planes. So in this case, we are, if this is your side view, this is front and this is top, we are saying that um, the side view here is shown in its true form or true shape, while the other two views are shown in a oblique manner, no? So here usually we take 45 degrees, but um, you can change this, no? You can have other angles aside from 45 degrees. Okay, so again, these three views are known as your pictorial views, while multi-view is not a pictorial view. So for ES1, we'll only be dealing with these first two views, no, the multi-view and isometric view. So for first long exam, first exam, it's mostly it's only up to multi-view, while isometric view will be for your second and third exam. Okay, so in the first portions, the multi-view, this is more of a how could I say, it's more technical, no? So you can actually just follow certain steps and you will be able to find the answer. But in isometric, there is a level of imagination required. You need to readily, we call it sometimes we call it in ES1 as a 3D mind, no? So we can, it's like saying that we can take an object, um, then try to imagine it in space, and we can rotate it in our mind, no? So it's a very useful uh, skill, if I could say, it's a very useful skill when we try to do isometric drawings. But for multi-view, a 3D mind will also help you with this, no? But if you are very limited, or if the 3D imagination is not innate to you, then in multi-view we can just follow step-by-step rules, no, to find the answer to whatever problem we are trying to solve. Okay, so again, here are just the key differences of the multi-view and isometric view. So again, these are the two views that we'll be using in ES1. Multi-view is again just a collection of 2D drawings that work together to give us an accurate overall representation of an object. Uh, it is an orthographic projections, that is saying that your visual rays are parallel to each other and perpendicular to the plane of projection, meaning walang ano, no, walang vanishing points. Okay, so the isometric view is a 2D representation of a 3D figure. It is a pictorial type of drawing, and the lines are parallel to the three main axes, and they are true in scale of the length. So meaning, 1 unit, again, what I said earlier, no, 1 unit in the x-axis is equal to 1 unit in the y is equal to 1 unit in the z-axis. Okay, so lastly, lines not parallel to the three main axes are foreshortened in this view. So more of foreshortening when we proceed to, I don't know, to to the isometric techniques. Okay, so let's now try to imagine what these reference planes are. So here are just the common observations. So I've touched on this earlier. We have the top view, front view, right side view. We have HRP, which stands for horizontal reference plane. FRP is frontal reference plane, and PRP is your profile reference plane. Okay, so I'm sorry for the background noise last time. Uh, okay, wait. Okay, I think it's okay now. So to to better give you a an imagination of how these reference planes are produced, let's try to imagine an object now. So I'll just do it in Photoshop, and let me just create a new canvas now. Okay, so say for example we have an object, and I'll just draw a random object now. Let's say I want to draw a cylinder. Hmm, let me increase the size now for hmm I'm sorry, opacity is down low. Okay, let me bring that back to 2. Okay, let's say we have a cylinder, and this is a cylinder in 3D space now. So if we want to accurately draw the cylinder into pen and paper, we need some way of projecting it. So we've already talked about the different types of projection. Let's do multi-view projections. Okay, the best way I can let you imagine the multi-view projection is to imagine a glass box that is containing the cylinder. So yes, try to imagine this the black box, and if we want to let's just say that we are looking at this glass box from this angle right here. So this is our line of sight now. Line of sight. If we look at this, we will see something that looks like a rectangle. Tama? And if we're looking at it from the top view, we should be, if it's a regular cylinder, we should see just a circle. Okay, so this glass box, this is actually our reference planes now. So this is our uh, top view, or the horizontal reference plane. This is now our front view, or the frontal reference plane, and this one is our, this side view here is our side view, or the, I'll just draw it here, perspective reference plane. Okay, so what we are trying to do here is we try to imagine that we are unfolding this um, glass box right here now, or our viewing box, so to speak. So if we try to unfold it, we should get something like this: one side, this side, and we have two more sides. Okay, and this is the folding line. So okay, and let me just expand my working area a little bit more. Okay, I think that's enough. So if we try to unfold this, and let's take a look at the projection now. For example, if we try to look at the top view, so if this is our top view, and let me label this as HRP, then this is our FRP, this is our PRP, right? So if this object were to be projected into this glass box right here, looking at it from the top view, again we will see, and let me use a different color now. On the top view, we should get something like, and if we project it into the frontal reference plane, we should get something like, yeah. And similarly, if we project natin on the PRP, we should get something like this. Okay, you see, I hope you can imagine this class now. So if we draw it here on our unfolded glass box, we should get something like, yeah, okay, something like that, siguro. Okay, and if you look at the other three planes, so this is actually the same as PRP, but instead of being on the right side, this is on the left side, right? Pause this one. This is the same as your HRP, but instead of being at the top view, this is actually a bottom view. And similarly, ito, this is the same as your FRP, but instead of the front view, again, it's the back view. Okay, so to readily imagine this object, we only actually need these three now. And we call these three as your primary reference plane. Reference plane. Okay, so the primary reference planes are HRP, which is horizontal reference plane, FRP, frontal reference plane, and PRP is our perspective reference plane. Okay, so if we were to draw this primary reference plane, it would be very arduous, no? If we were to always draw this square uh, viewing sides as to, or viewing planes as to speak, no? So what we usually do is, instead of drawing the boxes, we just draw the folding line. Okay, the folding line, this folding line here separates the two views, and it's more appropriate because this glass box here is infinitely expanding now. So it's sort of easier if we just draw the folding lines here. Okay, so if we try to draw that, we should get something like, and I'll use a black. This is now our, anything at the top of this folding line is our HRP. Anything at the bottom is our FRP. And this one to the side is PRP. And to this left side of this vertical line is our FRP. Okay, so that's how we draw our um how we draw our multi-view projections. Okay, so let's go back to our cylinder. Now let's just take a point on our cylinder now. So let's take, if this is our cylinder, and I'll draw the top view. If this is the top view of the cylinder, let's take a point somewhere here. Okay, let's call this point P. Okay, so if we have point P here, if this is our point P, if we were to project it upwards, it should be, and let me use another color for this one. This point P projected, should be somewhere there, and it should be this distance. I'll just call this distance A now. This distance, it's a distance away from this folding line. So if I draw this one, A, this is where, and I'll mark it with a crosshair now. This is where P should be located. Okay. Now, if I were to project it in the frontal reference plane, it should be somewhere here, P, and it's this distance, and let's call this distance B, away from this folding line right here. Correct? Okay. So it's B distance away. And what we'll notice is if we line up the horizontal and the FRP, so we are unfolding it again, they are actually collinear, no? Meaning that if we draw a perpendicular line passing through this point, if we draw this perpendicular line here, point P will always be along this line, okay? And we know that it is B distance away, so this is where point P is. Similarly, if we take P and project it somewhere here, it will be projected as this point, okay? Project it again, adjacent views, and this is what we call as adjacent views now. So HRP is adjacent to FRP, FRP is adjacent to PRP. Similarly, PRP is also adjacent to HRP now. If we did a folding line here, then we can say this is PRP, or this is a folding line separating this reference plane here and this reference plane here, okay? And let me just erase this. So when we have two adjacent views, their projection should be located in a line perpendicular to the folding line, okay? So this line here is perpendicular to the folding line, okay? Now notice this point P right here it's actually the same distance as this distance A, okay? So it's this is the same distance, okay? And we can use this property to complete a view if we were to be given two views, correct? So this is again point P. So we've located point P in the horizontal reference plane, in the frontal reference plane, and in the perspective reference plane. Okay, I hope you given you some idea of how to imagine these reference planes now. Now, now that we have our primary reference planes, let's now try to imagine what an auxiliary reference plane would look like. So auxiliary reference planes are labeled as ARP, and depending on how many auxiliary reference planes you create, you can have multiple auxiliary reference planes. So for this case, this is the first one, so we label it as ARP1. If you add another auxiliary reference plane, then we label it as ARP2. Okay, and if, for example, we create another one here, so this is this folding line right here separates ARP2 and ARP3. Okay, so let's try to imagine this one when we are doing our glass box now. And let me switch to full screen view here. Let me just check. Okay. Okay. So if I switch to full screen view, no, sorry. If I want to create a auxiliary reference plane, and let's just say I'm trying to create an auxiliary plane that is, and let me just copy this now. Let me duplicate this. Okay. Now, if I want to view it at a perspective that is different from the primary reference plane, I'll have to create an auxiliary reference plane. Okay, so let's just say, for example, from this horizontal reference plane, I want to view it at an angle that is something like this. Okay, and let me use a different color. Let's do This is a so this is a folding line separating HRP versus ARP. Okay, so what we are actually doing here, if we try to relate it to our original glass box now, this ARP will be something that looks like, let me erase this one. It will be actually something like, so it's like slicing your glass box and viewing it from this angle now. See, so it's like viewing it from this angle. So point P now, if we try to project point P, it should be something like this. Okay, and notice that this point P right here, and this is our folding line now, because we are creating the folding line right here from HRP, this view, we are projecting it to the next view, or this is now our adjacent view now. So from HRP, we are trying to look at it from an auxiliary reference plane at this particular angle. And if we look at the glass block, it should look something like this, where this is your folding line, this folding line, and let me use teal. This folding line right here is this folding line here, right? So if you look at this, the folding line, the distance of P from the folding line is actually equal to B, which is the distance from this point to this folding line. Okay, and true enough, you may notice a pattern. Huh? When we talked about distances from a particular folding line, it will always be equal to the distance two views away from it. So what I mean by two views is, if this is your view you are trying to manipulate, this is one view away because it's adjacent, and this is two views away, so that's one, two. From here, one, two, two views away. So distances in multi-view projection can be copied two views away uh, from wherever reference plane you're working on. Okay, so later I'll show you the module, and we'll do some exercise now. So this is just conceptual basis on how we do the techniques. Okay, so if we were trying to unfold this auxiliary reference plane right here, so that's like saying that you are doing something like this now. This is the top view, or the HRP, and para mas malinaw, I'll just draw HRP right here, and the auxiliary plane is ARP. And if you draw point P, let's see point P now. Point P, we project it. You'll notice that this same line of projection here, this is where we'll find point P again. Okay, and the distance here is equal to B, so it's B units, this B unit here, B units away from the folding line. Okay, that's why if we try to project, so if we were to complete this view now, we'll just project point P downwards, creating a perpendicular line, copy this B distance here. This is where, oh sorry, this is where point P should be located. Okay, so my drawing may be a little bit off now, so yeah, I'm just eyeballing this. but you get the idea, no? Okay, so if we were to draw another auxiliary reference plane, then we are just slicing your glass box, or we are trying to look at different angles in this glass box now. And notice that um, all adjacent reference planes to the previous reference planes is orthogonal. Okay, so that is, when I say orthogonal, so if you look at this, HRP is, if you look at the edge views of HRP, no, HRP will be something like this, and I'm looking at HRP from its edge. It's perpendicular to FRP, and this is your FRP. Okay, so all adjacent views are perpendicular to each other. Okay, so if you look at this auxiliary reference plane right here, this auxiliary reference plane and your HRP, they are also um, they are also perpendicular to each other from this, looking at this particular folding line right here. No? So if you try to um, rotate that in your head, no? Pagka we look at this from this particular angle, so if this is your line of sight, then you'll also see that this is your HRP and it's perpendicular to your ARP right here. Okay, so it's maybe a bit hard to imagine right now, but eventually, once you get used to drawing multi-views, this should come natural to you now. Okay, so let's now try to do our modules. So let's go to let me just check at the last slide. So let's just finish this slide now. So any ARP other than the primary reference planes. So this one, these are the, again, primary reference planes are referred to as, oh, happened, discard. Okay. So any ARP other than the HRP, FRP, and FRP are referred to as ARP1, ARP2, and ARP3, depending on the order of which you create those auxiliary reference planes. The views produced by these ARPs are called the first auxiliary view, second auxiliary view, etc., respectively. Okay, so let's try to draw an adjacent view, no? And for this one, let me use our modules. Okay, this is page 1. Let's do page 2 of our module. Okay, so let me just readjust my working area. Okay, okay. So let's do this one. No? So if we have wait a minute, class now. Maybe it's better if I show you using Active Inspire. Okay, wait a minute, class. And let me just replicate this once now. So I'll draw my reference plane first. Sorry. I'll draw a horizontal one. And let me draw a blue line now. Horizontal is vertical. So these are my primary reference planes. And draw. Okay. Let me label these points as, this is HRP, this is FRP, and this is FRP, and this is your PRP. Let me replicate. We have point 1, point 2. Okay, we have something like point 1. We have another point 2 here. Okay. Point 1 and point 2. So I'll just draw. Since they are the same point in adjacent views, they should be, if you draw a perpendicular line to this reference plane, there, that is the location of your point view now. So if I do something like that, so this becomes your, I'll just estimate point 1 is somewhere here, point 2 is somewhere there. Okay, so let's try to draw this. We'll try to draw this 2 points and project it in this PRP right here. So the first step we do is, again, if it's adjacent view, if we draw a perpendicular line, and again, from this point class now, you can actually use your triangles and ruler to create the perpendicular and parallel lines. So no need to do the geometric construction techniques. So I'm assuming Jay already taught you this, pero I think I can show you here. So if I have something like, um, if I want to, let's say, create a perpendicular line from this FRP kunwari, and I want it to pass through point 2, then what I'll do is I take my triangle, then I take my ruler, okay, and using your ruler, we want to line, this is what we'll do now. So we'll line up the ruler with the base of the triangle, and what we'll do is slide the triangle along the ruler. Okay, so that's from here. If we were trying to create a perpendicular line, then we just slide it passing through point 2 like so, then we can create the perpendicular line. Okay, similarly, if you want to create a parallel line, so kunwari lang you want to create a parallel line to this folding line right here, and you want to place it somewhere here kunwari, then you can just slide it and draw again. Okay, so that's how you do parallel and perpendicular lines using a ruler and a straight, I'm sorry, using your triangles and a straight edge. Okay, let's do that one more time now. Let's erase this. So say for example, I have a, let me draw a random line now. This is a random line, and I want to create a parallel line to this random line passing through, let's just say, this point right here. Then instead of using the parallelogram technique or the rhombus technique, what I'll do is just line one side of my triangle with the line I want to create a parallel line to, then use my ruler, line it up with the base of my triangle. Then what I'll do is just transfer, is slide this triangle along the ruler till I reach the point, and now I can draw a parallel. Similarly, if I want to create a perpendicular line to this line, let's just say line 1, this line 1 is line 2. So at this point, line 2 is parallel to line 1. Now, if I want to create a line that is perpendicular to line 1 passing through this point, then again, what I'll do is align my triangle up with my line, then take my ruler, this is the baseline, then I'll slide my triangle now. So I'll slide this triangle along my ruler like so until I reach the point. Then I can now create my perpendicular line. Okay, so that's how we create parallel and perpendicular lines using only a triangle and a straight edge. So hopefully that will definitely speed up your process class now. Because right, it will be very difficult to do geometric constructions if we were doing multi-view projections now. If you have to, you can only imagine the amount of time it will take if we were to project this from this reference plane to this reference plane using geometric construction techniques. So again, if nasa exam na tayo, you can only use the sliding triangle technique if the problem is not a geometric construction problem. Okay, if the problem specifically notes that you need to do geometric constructions, then bawal gamitin yung sliding triangle technique. Okay, so I hope that that's clear class now. Okay, so where were we? So let me just close this now and I'll erase this portion and just select it on. Mm, I can't seem to erase it. Anyway, it's okay. Let's use a large eraser. Mm-hmm. Okay, I finally have erased it. And let me also erase this. Why can't I erase? Oh, because it's a line. Okay, sorry. Okay. Okay. So again, we want to first project this 2 points into this PRP or the perspective reference plane. Okay. So the first step is again we want to create a perpendicular line passing through this point points 1 and 2 perpendicular to this folding line right here. Okay. So we'll do a perpendicular line. Obviously, you'll use your ruler for this now, your triangle ruler for this. I've projected my 2 points, and um, again, as I've elaborated earlier during this discussion, now, is that by the way, am I viewing it correctly? I should be viewing the whole screen, something like that. Anyway, I hope I didn't make a mistake. Anyway, so as we viewed it earlier here from this discussion, when we talk about distances, we always take distances 2 views away from the view we are working on, and for the projection line is taken 1 view away from the view we are working on. So in this example, is PRP 1 view away from it is this is this is one view away, and this is two views away if we are working from this view. Okay, so one view away will be this one, so that's why we did projection lines here. Okay, so this is a projection line. Point 1 projected along this line, which is perpendicular to this line. Okay, then for distances we do two views away. So if this is PRP, this is one view, two views. Okay, so we copy this distance, copy this one, then project it. So then let's strike a, okay, now let's copy one as well. Okay, then we strike another arc here. Okay, so this is the location of point 1. This is location of point 1. Well, this will be the location of point 2 in our perspective reference plane. Okay, so let's look at the module. After that, we are trying to look at, this is the PRP, and we are looking at another view, the auxiliary reference view. Okay, so if we do a perpendicular line, so let's just say we are drawing an auxiliary reference plane here. So this is now your, this is the folding line separating your PRP, and at the bottom is your ARP1. And since we're only doing one reference plane, so we'll just do ARP. Okay, and let me adjust this a little to prevent any confusion. I'll just adjust it something like that. Okay. Okay, so the first step is, again, we project this perpendicular from this 2 points right here, perpendicular to this, and let me label, this is your PRP, this is ARP. Okay, so again, the first step is to draw a projection line that is perpendicular to this folding line, no? And for my case, I'll just eyeball it, no? But obviously for you guys, ang kailangan nyo gawin is you need to use your the sliding triangle technique. So I'll just eyeball it. That is my projection line for point 2. This is the projection line for point 1. Now this is the view I'm working on now. So again, I'm working on this view. I'm working on this view, and I'll just label it 0 view. This is my view. Then I want to measure two views away. Okay, so again, projection lines is one view, adjacent view, but distances are two views away. So that's 0 view, one view away. This is two views away. Okay, so if this is two views away, then I should take my distances from this. Okay, so a common mistake, class, when we copy distances is the students they copy the wrong distance from the wrong folding line. Okay, so what they'll do is they mistakenly copy this distance right here, and they copy it here. So that's wrong, no? So we always measure it in terms of the folding lines. Okay, so if this is your first folding line, so this 0 views away, first view away using this folding line, second view using again this folding line. Okay, so we measure from this folding line here. Okay, so we don't measure from this folding line because that's the third folding line from this view now. So we measure two views away, so that's one folding line, two folding lines. Okay, so if you copy this one too, then strike an arc, and let's copy one again, one folding line away, two folding lines. Maybe copy this distance, and we'll strike an arc, and kulang yung ginawa ko na. So let me just extend my original line. So from here we extend. Okay, so this is now my final answer. I'm drawing this one. This is 0.2 as projected into ARP, and this is 0.1 as projected into ARP. Okay. Okay. So hope that makes sense, class, now. And just to give us a bit more practice now, let's try to do one more. And let's just say I want to create a reference plane from FRP. Okay, FRP. So this is now FRP, and this is your ARP, and I'll call this ARP2, and I'll label the first one as the first auxiliary view. Okay, so if I'm drawing it from FRP, let me, this is FRP. So if I'm drawing from here, then the projection line should be based on FRP, correct? So again, we do projection lines. Again, for your case, you should do this using a triangle and slide it across a ruler. But again, in my case, I'll just have to eyeball it. No? Again, this is that's perpendicular. So from there, I'm now faced with two. I have now two options here, class, now, because if this is my zeroth view, example, this is the view I'm working on, then two views away should be, this is one third view away, this is two views away, correct? But similarly, this is also, PRP is also two views away from ARP1. Okay, so this is 0, 1, this is two views away. So we can actually use this distance or this distance. No, it doesn't matter because actually they are equal. They are, this distance right here is equal to this distance right here. Because if you remember, when we got these two lines, these 2 points right here, point 1 and point 2, we actually used point 1. We actually used this HRP as basis for the distances of PRP view. So it makes sense that they are equal. No? So if I were to draw point 1, then I can use either HRP or PRP. So in this case, I'll just use the PRP distance. So again, it's this folding line, one folding line, two folding lines. So we measure it from this folding line right here, not from this folding line. Okay, so we copy it, transfer it there. Okay, then we copy the distance of, and since they are equal, just to show you, then I'll just copy it from HRP. It shouldn't really matter now, as long as it's 2 views away. Okay. Now I can strike an arc, and this intersection points right here is where I'll find point 1 and point 2. Okay, so let's go to practice. Let's do this practice, and maybe I can do it in this view now. So let me project it. Oh, sorry. Let me use my Photoshop view. So hopefully it's um in its full view right now. So let's just try to practice with this one now. Okay. We are given point 1, point 2, and a line AB. So first, let's try to draw the projection lines. So let me use this one. Point 1, projection downward. So one tip, class, is whenever you draw, you're working with multi-view projections, um, it's always easier if you draw the projection lines first. So here, I already know A and B, and for this case, I can just connect A and B now because A and B are already given. But for points 1 and point 2, I have to use the sliding triangle technique to get the perpendicular lines, these perpendicular lines. But of course, I'm working with Photoshop, and in Photoshop, I can just press Shift and it will create a parallel, a perfectly parallel, or perfectly perpendicular line for me. Okay, then I'll do this one, projection line. Also do this one. Okay, so if you notice, point 1 should be in this projection line right here, but we don't know the distance, and we can't find out the distance because if you're working with this um, area right here, we need 2 views away, no? So if you were to measure from, for example, from the top, so it's 1, but we don't have any additional views, so we don't have basis for measurement. Now if we'll also do it from this side, so we'll do this is the 0th view, or the view we are working on. So there's 1 view away, 2 views away, but the ARP2 right here is still blank, so we don't know the distance, right? But an interesting thing here is this point 1, this is the projection line of point 1, correct? So point 1 should be located somewhere here, but point 1 is also within this projection line right here. So this intersection right here should be the location of this intersection line, should be the location of point 1. Let me just label this. Okay, I'll just increase. Okay, similarly we can use that analysis for point 2 as well, no? So we have point 2, this is the projection line of point 2, this is also the projection line of point 2, therefore this is where point 2 should be located. Okay. Yeah. Now let's project them into, we have point 1, point 2, A, B, or, and let's try to complete ARP1. So in ARP1, we project point B and point A. We will do, and we'll also project this one. So we are working on this reference plane. So 2 views away is 1 view, 2 views. So we can copy this distance A. So to simulate a compass, let me just draw a circle. If I draw an ellipse tool, sorry. Okay, and use a red stroke with no fill. Let's just do two. Okay. Okay. Oh, sorry. Let me rasterize. And okay. Okay. And let me group. Okay. So this circle right here will be my compass now. This will be my pseudo compass. Okay, so if I measure distance of A, copy this distance A right here. A should be located somewhere there. Then I'll copy distance B, which is this one. B. So this should be location of B. Okay, let me hide my compass, quote unquote compass now. So this is A, this is B, and if I connect a line from here to here, that should be my, let's just do 4. For my final answer, this is A, this is B. Okay, now let's complete all views. Let's project it dito sa ARP2. Again, the first step is draw a, and since I have no ruler now, I'll just do this technique. Okay, then I'll project this one upwards. Okay, again class, for your case you should use the triangle method. Okay, now I can copy distances again, and again this is the view we are working on, ARP2. So 2 views away will be 1, 2. We are working with this FRP reference plane right here, which is, and we'll use this, this is the first folding line. We'll use the second folding line as the measuring reference point. Okay, so we are completing, let's do 2 first. So 2, 2, transfer to, and this is where 2 should be. Then let's transfer A. A is very far, so that's A. So again, this circle here class is just my way of mimicking a compass now in Photoshop. So A should be somewhere here, and I'll have to extend this line now. Oh, okay, something like that. Okay, okay, so I'll extend that line and again use my pseudo compass. Measure this one right here. One. Okay, one should be, and last is point P, and using my pseudo compass, measure this out. P right here. Okay, so let me see. This is now point 2. This is point 1. This is point B, and this is point A. And since AB is a line, we'll connect AB. So this is the completion of the given views given the line AB and points 1 and 2, and we've filled out ARP1 as well as ARP2. Okay, um let me take a short break class now, and I'll continue this on another video, or I'll continue the module, I mean, in another video. Okay, peace out.